Okay, so what are we gonna do today? And we were reviewing the homework. And we went over the different procedures that you have to follow when you're completing an experiment. At the end, see, of every procedure, you're gonna find that you have to record your data. How you're gonna record your data? What are the tools that you're gonna use to record your data? And we use usually a table just to organize the information, and then we translate that table into a graph. A table and a graph, they are not the same. Table, you organize your information in there, still it's not good to see the patterns between the independent and the dependent variable. And when you translate that data into a graph, you're gonna be able to see the relationship between the independent and the dependent variable better. And that's why when you're gonna write your conclusion, instead of looking at your table, you're gonna look at your graph. Okay? So far we have three types of graph. Pie graph, we have bar graph, and then we have line graph. When are you going to use a pie graph? And you have the definition over there. And you know, since you were in elementary, that every time that you want to represent percent, you're gonna use a pie graph. Because pie graph, they are used to represent part of a whole. Okay, now bar graph. When are you going to use bar graph? You're going to use bar graph when you want to compare. See over here? Compare things between different groups or different categories. Okay, when you want to compare different groups, then you're going to use bar graph because you can see the difference like easily. Remember, we're talking about graph, tables, is to organize the information. Graph, they are created so you can establish the relationship between the dependent and independent variable, or you can see the relationship better. Okay, when are we gonna use the line graph? Okay, we are gonna use line graph when you want to see with accuracy and precision the relationship between the independent variable and the dependent variable. For example, over here I have that the independent variable is the different type of animals. Okay, so there's no way that I can find over here how many people we have in a rabbit and a half. I cannot do that because you cannot have a rabbit and a half or one or half of the rabbits. But over here, you can do that, or you can establish that relationship because you want to know, okay, what was the population in the year 2003. You go all the way up until you touch your graph, and then you're gonna be able to move to the left to find that information. Okay, so when you want to be precise of the population of the year, no, the population of bears in there. Now, when are you gonna use line graph? When you want to see like accurate representation of your data, when you want to see, when you want to look for the values in there, see, when you want to see what is the independent variable that goes with every dependent variable, is when you're gonna use a line graph, in other words, okay? What are the graphs that we're gonna use in class? Mostly bar graph when we are comparing, and this one when we are trying to establish a relationship between the two variables. Now, we're gonna continue with graph. First, we're gonna discuss pie graph. How are you gonna read your graph? Usually when you're reading a graph, you have to pay special attention to the title. The title is giving you information. Also, if you have, let's see, this is the title of your graph, and pay special attention over there because you can see have information about the independent and the dependent variable by looking at the title, and also sometimes they're gonna have a legend in there just to help you understand the information that is in there. On the first one, remember that we're going to use pie graph to represent part of a whole. If you add all the percent that you have over there, the total is 100%. Okay, now traffic analysis. In this case, when you use at the legend, remember you have to pay special attention to that because it's giving you a hint. Traffic analysis, are you analyzing the traffic that you have in street? No, because as you look over here, the blue is representing website, the red is representing flyers, radio, and ad. And you don't have those type of cars running in your street. So when they are looking over here at traffic analysis, they are analyzing your online or your internet traffic. 60% of the time that you're going into the internet, you're going to a website. Okay? That's how you read a pie graph. 10% of the time that you are going to the internet, you are looking for the radio station. That's the information that you can get from a pie graph. Over here, remember the title is super important. You have the title over here, and you have your legend. Okay, here the legend is giving you a hint. Favorite pizza topping. What is your independent variable? The legend is giving you that there, because the legend is representing the independent variable. So in this case over here, the independent variable is the different places that you're going when you're going to the internet. In this specific pie graph, the independent variable is the topping of the pizza. Okay, the topping of the pizza. Now, how you gonna read this same? See, of 100 times that you are ordering a pizza or people are ordering pizza, 50% of the time, people they want a pepperoni pizza. A pepperoni pizza. So let's say, and this is another information that you can get from your graph, that you have 250 people or individual ordering a pizza. What is the amount of that people that is gonna have a pepperoni pizza? You can multiply this by 0.50 and then you will get that. If I'm no, okay, 25. So if my math is not lying to me, out of 250, 125, which is half, 125 of the individuals ordering pizza, they're gonna have a pepperoni pizza. Questions about that? You can do the same with the other. Okay, let me see. Supreme, only 10%. Out of the 250, only 25, because it's a 10%, they will have a Supreme pizza. Okay, that's the information that you can get from a pie graph. Remember, you have to pay attention to the title, you have to pay attention to the legend. Okay, we're gonna continue. Now we're gonna continue with the bar graph. One more time. Okay, now what's gonna happen here in the bar graph, that always you're gonna have a title. Okay, always you're gonna have a title. Keep that in mind because you're gonna be creating graph for your lab reports, and if you have a graph over there without a title, I'm gonna take points away. Now, in a bar graph, you learned that when you were taking math. Okay, bar graph, you have an x-axis, which is the horizontal one, and then you have a y-axis. You didn't have that in the pie one, but over here you have two axes. You have the x, which is the horizontal, and then you have the y-axis, which is the vertical one. Always in the x-axis, you're gonna graph the independent variable. That's what you don't need over here, a legend, because always you're gonna have the independent variable in the x-axis. Independent variable. If the independent variable is in the x-axis, what is gonna be graphed on the y-axis? Si no es Juana la hermana, dependent variable. Okay, and that's super important because sometimes you do that, see, the other way around, and that's totally wrong. Because remember that the independent variable, you have control over that. You are manipulating that. The dependent is going to change in response to the independent variable. Another information that you can get from a bar graph, look over here, see? Different type of animals, okay? But what is the animal that most people have is super easy. See, that's what we use about graph, because you put this information on a table and you're not going to be able to see that. But you put this information on a graph right away. What is the animal that most people in this town have? And then you have that the cat over here, mira, against your prediction that the cat is the animal that most people in town are having at home as a pet. Okay? Now, see, like the rabbit over here, the least, what is the animal that you're gonna find that has the least probability to be, like just to be a pet? So you go to a house, they have pets in there. Are you gonna be able, so you have a high probability to find a rabbit? No, because that's the least, when you look at the bar table, that's the smallest bar that you have in there, meaning that not too many people, they are having a rabbit as a pet or a mascot, okay? That's the information that you can get from a bar graph. What is another information that you can get from the bar graph? Just remember that when you were analyzing the pie graph, you were using the percent. Over here, since you are comparing different categories, are you going to use percent? No. So let's say that you want to know the sample that was analyzed, so the number of people that were part of this experiment. How can you do that? And you will have to come over here. See, 4, they were having rabbits. I don't know, 8, they were having a dog. So you have 12 over here. I think that 11, they were having a cat. 23, okay, goldfish, 6, 29, and then hamster around 5, 29, 34. So the amount of people that was tested in this experiment, 34. See that on the other graph I was using the percent, and I can use like 100 to 150. Over here I cannot use any amount of people because the graph is giving me the total amount of people that were part of the experiment. And how you're gonna do that? By looking at the numbers that you have here to your left. Okay, you count that. 4 plus 8, 12. 12 plus 11, we have 23. 23 plus 6, 29. 29 plus 5, 34 people were tested. Okay, that's the information that you can get from there. So over here, the same story. Always in the x-axis, you're going to have the independent variable. You're going to have the dependent on the y-axis. And see, if you want to look for, all right, let me see, you have pencil, scale, pen, sharpener. You're analyzing what are the school supplies that students need more, okay? A number of supplies. If you want to know, okay, how many supplies were like observed in total, you can do the same. Here you have the number of pencils, and here you have the number of scale that was using. Here you have the number of pen, okay? And you can find the total number of supplies that were observed when students were asked about the supplies that they were bringing to school. Now, in this case, you have here a number of supplies. Are you gonna be able to know how many students were tested? I don't think so, because maybe student, and this is when probability is playing a role, and you don't have to know about that now. Maybe the students that brought a pen also brought a sharpener. But see the difference over there? So over here, there's no way that you can know the amount of people that were tested. Different in this place that the dependent variable was giving you the number of people. Over here, you don't have that information. So you have to be very careful when you're reading that. See? And what is the conclusion that you're gonna write here? That even though pen and pencils they used to write, a student that bring more pencils to school than pen. Okay, and even though they use a lot of pencils, they are not bringing enough sharpeners to school. See, that's another conclusion that you can draw from there. That there are some students that are bringing pencils that they are not bringing the sharpener to sharpen during class. Those are conclusions that you can get from your graph. Okay, so the last one is the line graph. Line graph. And we are gonna use them a lot, okay, especially in the chemistry class, because in chemistry we want to know with precision and accuracy, okay, what is happening when the independent variable has certain values. We want to know the exact number of the dependent variable, and we use line graph for that. Okay, when you want to know at any given point of your independent variable what is the value of your dependent one. Information that you can get from here. Remember, the title is super important. What are you analyzing here in this one? You are analyzing the bear population in Emerald Forest, the bear population over there. You have the population here in thousands, so you have here a 40, you know that is 40,000, okay? And what is the independent variable? The independent variable is the years. So as the year are changing, the population of bears in Emerald Forest is changing in there, in thousand. Okay, over here you have the same example. Independent variable is the day of the week, days of the week, okay? And even though, see, you don't need that, they are putting that over there, okay? See, you have the title over there. That's a very simple title. Usually you write the dependent, usually when you're writing a title of a graph, you're writing the dependent, let me put that over here, dependent variable versus independent variable. So in this case will be muffin sold versus day of the week. Okay, so it's very simple. Half of the title is missing in there. Okay, but still, see, you are capturing the essence in there. So if I want to know how many muffins were sold on Wednesday, so this is Monday, Tuesday, Wednesday, I go all the way up until I touch my line graph, and then I move all the way through the left. So around, okay, 6 muffins that day. Can you sell a muffin and a quarter? Or can you sell, let me see, 1, 2, 3. I mean, 1, 2, 3. I'm going here. And around 7. Around 7 muffin. Because you cannot sell a muffin and a half, or you cannot sell a muffin and a quarter. So whatever is here in the middle, that will be 7. Okay? That's how you look for your information. Can you go the other way around? Yes. Let's say that you want to know which day you were selling 12 muffins. You go all the way through the right until you touch your line, and then you go all the way down. And what is the reading here? Saturday. Saturday you were reading, because this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, let me see one more time. 12, and I go the way down. No, it's on Friday. So on Friday you were selling a 12 muffin that day. That's how you get information. Now, what are the conclusions that you can draw from this graph? as the weekend is approaching, you can see, your line is going up. Yeah, I don't know if you have learned about slope, but you have over here a positive slope. Meaning that as you are increasing here the independent variable, the dependent variable is increasing as well. So you have a positive relationship here. And that means that as the weekend is approaching, what's going to happen to the amount of muffins that you're selling is going to increase. Okay, so if you want to sell a lot of muffins, are you going to sell that on a Monday? No. Are you going to sell that, let me see over here, on a Tuesday or a Wednesday? No, because if you look over there, that's the minimum point. You're not going to sell that day muffins because you know that you're going to come back home with all of them. Okay, so as the weekend is approaching, you're going to be selling more muffins, so that's the day. So from Friday all the way to Saturday are the days that you're going to bake more muffins. And here happens the same. See, the line went up, meaning that the population was increasing. Okay, you can infer, remember that you don't have to be right, you can infer by the behavior of the graph that maybe that Emerald Forest was implementing a extinction program. See, they were protecting the birds over there. See, there was not people were not allowed to kill. See, the season for killing birds was not allowed that between those years, and the population of birds was increasing over these years between 2004 and 2005. See, you have a horizontal line. That means that the population was stable, it was staying the same, constant. So you have 30,000 birds in there, didn't go up, didn't go down, same. Probably they were having, a fertilization process problem. Females, they were not getting pregnant, and then it was unable for the population of birds to increase. And all of a sudden, this increasing one more time. Now, you're going to look for possible cause over here of trouble. You're going to look at that flat line, because it was between 2004 and 2005 that the populations didn't increase, just stayed the same. Okay, so if there was a problem, was between that year. Probably they have wildfires. You have to look for more information. Some of them, they were dying, but still the females, they were able to reproduce, and they have the same amount. They didn't suffer from that wildfire that was in that forest. That's how you have to read a graph. Always looking for the relationship between the independent and the dependent variable. In bar graph and line graph, the independent variable always is going to be located on the x-axis, the dependent on the y. Okay, and if you want to know the value of the dependent, you start with the independent, go to the line, go to the left. If you want to find the value of the independent, you come here to the left, go all the way to the right until you meet the line, and then you go down, and you're going to find your information. With all this information, I think that you can finish your ingenuity unit. Okay?